I am Aditya Basurajmani studying in Sri Venkateswara College of Engineering, Bengaluru. Today I am going to discuss about how to find the center of a given lamina. The question is like this. Determine the position of the centroid from the lamina with a circular cutout shown in the figure. Here are the some tips to solve the problems. First one is the centroid always lies on the symmetrical axis. Second one is identify the symmetrical axis, if any. Choose them as the reference axis. If no symmetrical axis is available, choose the left-hand bottom corner of the given figure as the origin so that the entire figure lies on the first quadrant to avoid the negative centroidal values. Third one is subdivide the given figure into known geometrical shapes and identify their individual centroids by denoting them with a Ci, where I is the number of subdivided shapes. Fourth one is enter the value in the tabular columns as shown below. First one is component, second one is area, third one is centroidal distance from y-axis, fourth one is centroidal distance from x-axis, fifth one is ax, and next is ay. Fifth point is indicate the calculations like enter the x into y values for the area and then enter the result. For the centroidal distance, enter the equation with the substituted numerical values like 3 plus 4 into 5 divided by 3 5 etc. The areas are negative if hollow and the centroidal values are negative if they are below the x-axis or left of the y-axis. Sixth point is compute the centroidal values as x bar is equal to summation of ax by summation of a and y bar is equal to summation of ay by summation of a. The centroidal value of a triangle is always 1 by third of the length from the base and 2/3 of the height from the apex. The centroidal value of the semicircle is always as 4r by 3 5 from the base of the semicircle, normal to the base or along the symmetrical axis. Let us discuss this problem. This is the diagram which we are going to solve today. It is an unsymmetrical diagram. Now let us divide the given figure into different components. The first one is rectangle. And the second one is triangle. And the third one is semicircle. The fourth one is circle. Now let us consider the first component as a rectangle. Here the rectangle is given with a breadth of 120 mm and the depth at 100 mm. To find the area of the rectangle, we have the formula B into D. Here 120 is the breadth and 100 is the depth. Therefore the answer is 12,000. Second, we will find centroidal distance from the y-axis. To find the centroidal distance from the y-axis, the formula is b divided by 2. Here b means breadth. The breadth is given as 120 mm. Therefore, 120 divided by 2 is equal to 60. The next we will find the centroidal distance from x-axis. Here the formula is d by 2. Here the d is given as 100 mm. Therefore, 100 divided by 2 is equal to 50. Next we will find ax. Here a means area. The area is equal to 12,000 into 60. Therefore, the answer is 7,20,000. The next we will find ay. Here a means area. The area is 12,000 into 50. Therefore, the answer is 6 lakhs. The next component we are discussing about is triangle. Here the triangle is given with a breadth of 120 millimeters and the height of 60. To find the area of the triangle, we have the formula b into d divided by 2. Here B is given as 120 and D as 60. Therefore the answer is 3600. Next, to find the centroidal distance from y-axis, that is x. The formula to find the centroidal distance from y-axis is b by 3. Therefore b is given as 120 divided by 3 is equal to 40. Next, the centroidal distance from x-axis, that is y, is equal to d by 3. Therefore d is given as 60 plus the distance from the x-axis to the base of the triangle is 100. Therefore plus 100 is equal to 120. Then next we are going to find AX. 3600 into 40 is equal to 144. Next, AY is equal to 3600 into 120. That is equal to 4,32,000. The next component we are discussing about is semicircle. Here in the semicircle, to find the area of the semicircle, we have the formula pi r square divided by 2. Here the radius is given 50 millimeters. Therefore, the answer is 3926.991. The next, centroidal distance from the y-axis is, that is x. The given semicircle is at the distance of 120 millimeters from the y-axis. Therefore, we have to add 120 plus the formula is 4r by 3 pi. Therefore, the answer is 141.22. The next, the centroidal distance from the x-axis, that is y, is 100 divided by 2, that is equal to 50. The next we have to find the AX, that is area into centroidal distance from the y-axis, that is 5,54,573.6. The next AY, that is area into centroidal distance from x-axis, that is 1,96,349.6. The next component is circle. To find the area of the circle, we have the formula pi r square, but we will get the answer in negative because we have to exclude the circle from this diagram. Therefore, the area of the circle is minus 1256.637. Then the centroidal distance from the y-axis, that is x, is equal to 60, and the centroidal distance from the x-axis, that is y, is 100 by 2, that is equal to 50. Next one is a into x, that is area into central distance from y-axis, that is minus 75,398.22. Next one is area into central distance from x-axis, that is minus 62,831.9. Now the summation of area is equal to 18,270.354. Next, the summation of AX is 1343.175.4. The summation of AY is equal to 1165517. Then next we have to find X bar. The formula to find X bar is equal to summation of AX divided by summation of A, that is equal to 73.1517 millimeters. Then y bar is equal to summation of ay divided by summation of a, that is equal to 63.793 millimeters.